You may have heard these called box and whisker plots before. I'm going to call it a box plot because that's typically what it's referred to in statistics. And I've given some data here about the first marking period averages for Regents geometry. In order to be able to make a box plot, you have to have your numbers in order from smallest to largest. So I'm going to take a minute and do that. And I believe I gave 20 numbers, so let's just double check. 1, 2, 3. Maybe I didn't give 20. Oh, because I forgot. Maybe it was 18. 18 numbers, okay. So to create a box plot, you need to have the median. And the median is one of those where you're inching towards the center. So 52, I would cross off 93. 60 and 92. 66 and 92. I don't want to write all over these numbers this time. And I end up with 82 and 82 in the middle. So obviously my answer is going to be 82. But if I had an even number of data and I needed to find the median, it would always be the average between these two. The two numbers. So 82 and 82. I know my average is going to end up being 82. You also need to be able to calculate quartile 1, which basically means like the first 25% is the way I think of it. Not actually 25% out of the total, which obviously out of 100, I'm thinking of the first 25 pieces of data, the first 25% pieces of data. So what we want to do is we want to say, okay, this is where our median lies. Then the first 25% is going to lie in the middle between these lower numbers. So again, I'm going to find the median, except I'm going to use the lower numbers only. 60 and 78 I'm going to cross out. So 71 is my first quarter. Quarter 2 is your 50% mark, which is not necessarily like your mean, that's your median. Your middle ground. Where do 50% lie? Above and below from that point. And quartile 3 is 75% mark. So I'm going to be thinking of the upper 50%, and in the middle would give me the 75% mark. Basically like the percentile of it. So 89. A lot of times they want you to put the interquartile range. And in statistics, we're going to use this range a lot more than the actual range, like from the very first number, like 52, all the way up to 93. We're going to use this interquartile range because it kind of eliminates any outliers or anything where you have these extreme lows and extreme highs. So it kind of takes out the first 25% and the last 25% and sticks with the middle 50%. Interquartile range is like the range from 25% to 75%. That's your range that you're trying to figure out. So for us, we'd be using 71 and 89. Interquartile range. You subtract the two numbers, and that would give you the range. So the formula for it is really the IQR is equal to quartile 3 minus quartile 1. And in our case, it's 89 minus 71, which is 18. So eliminating those super smart people and those people who are not doing their work, maybe they've been absent, and just focusing on the bulk of the class, the middle 50%, the range is about 18 points in there. So I wanted to take a minute and set up a graph that we're going to be doing our box plot on. And you have to plot certain data. You have to plot the two extremes, the minimum data and the maximum data. So the minimum data of our data is 52 and the max data is 93. So at 52, I'm going to place a mark, and I'm going to do this like above the graph. And this is going to be more of a sketch. And 93 is where they span up until. And then I need these quartile 1, quartile 2, quartile 3 represented on my graph. We could plot them with points, but I'm going to try to be a little bit less obvious with my points because I need to make something out of them. 82, 89. What we're going to do is we're going to box in the middle 50% of our class, or this geometry class that I'm representing. And the line down here is going to represent the median. So basically I have quartile 1 here, quartile 2 here, and quartile 3 here. So it's thinking, I want you to think of more like, I hate to write it on here, but like 0%, 25%, 50% of the people have scored above this or below this. 75% of the people have scored below this point, and up here is my highest point. That's where 100% of the data has been displayed below it. And what we do is we connect these with lines. So I'm kind of eliminating a lot of the people who have failed. If I'm looking at this box and whisker plot, they're not highly represented. Who is highly represented is the bulk of the students. And where did they lie? Between the 70s and the 80s is where they lie. So I'm kind of eliminating that I had a lot of mastery and people in the 90s, and I'm also eliminating a lot of the people who were failing. And the bulk of the students were lying in the 70-80 range for this marking period average. So a few things that I want to recap too is there is a formula for finding out if something is an outlier. Like too much of an outlier to the point where I don't actually want to draw this big whisker to it because it's way out there. And the formula is, I'll write it down. 1.5 times the interquartile range. So if I'm doing 1.5 times our interquartile range up here was 18. 1.5 times 18 should be 27, I believe. And what that 27 is representing is that, let's say you have quarter 1, which was 71. If you take away 27, do you have any values lower than this difference? Which equals 44. So are any of the values lower than 44? If someone got less than a 44, I wouldn't want to extend my whisker to them. I'd want to kind of put a dot, and then I'd actually have another dot and consider something else my minimum, and then my box and whisker plot. And the same goes for quarter 3. Quarter 3 was 89. So if I add 27 to it, did anyone score higher than 116? Well, obviously, no. If that would be too high of an outlier, too high of a point to include, so I'd actually put a dot at that point, but I'd pick the next highest one to be actually my maximum and create my box and whisker plot below it. And the last thing that I want to talk about was the 5-number summary. These 5 numbers that are located in this graph, what I consider my 0%, my 25%, 50%, 75%, and 100%. It's considered the 5-number summary. The minimum, quarter 1, quarter 2, or the median, quarter 3, and the max.